There are moments in human history when a single decision changes everything that comes after it. Moments where courage, risk, ambition, and fear collide in a way that pushes humanity beyond what it thought was possible. Space exploration is full of these moments, but one mission stands above almost all others in terms of danger, uncertainty, and the thin margin between success and complete disaster. This is the story of the most dangerous mission NASA ever sent into space. It wasn't just dangerous because of distance. It wasn't just dangerous because of technology. It was dangerous because of everything that could go wrong, did go wrong, or nearly went wrong at almost every stage of the journey. A mission where survival was never guaranteed, where engineers back on Earth could only watch and hope, and where the smallest error would have meant total loss. To understand why this mission was so dangerous, you have to understand the era it came from. The early decades of space exploration were not like today. There were no guarantees, no fully tested systems, no decades of refined data. Everything was experimental. Every launch was a gamble. Every calculation carried risk. Humans were sending machines, and sometimes themselves, into an environment that was completely hostile to life. Vacuum, radiation, extreme temperatures, micrometeoroids, communication delays, and worst of all, the unknown. Now imagine placing not just a machine, but $1 billion scientific mission into that environment with no possibility of rescue if something went wrong. That is exactly what NASA did. The mission began with a purpose that sounded simple on paper: explore deep space beyond Earth's orbit, gather scientific data, and push the limits of human technology farther than ever before. But behind that simple description was a system so complex that even the engineers who built it admitted they did not fully know how it would behave once it left Earth's protective environment. Every component had a risk factor. Every system had a failure mode. Every backup system had its own backup system, and still, no one could guarantee success. The spacecraft itself was designed to survive conditions that had never been fully tested. Radiation levels beyond Earth's magnetosphere were unpredictable. Temperature swings could destroy delicate instruments in seconds. Even the communication system relied on signals traveling millions, sometimes billions, of miles through space. Signals that could be distorted, delayed, or lost entirely. And yet, despite all of this, the mission launched. The first stage of the mission was the launch itself. On the surface, launches often look smooth, controlled, even routine. But in reality, launch is one of the most dangerous phases of any space mission. Millions of pounds of thrust must be perfectly balanced. Fuel must ignite at precise timing. Structural stress must remain within limits that are constantly being tested in real time. If anything goes wrong during launch, there is no recovery. For this mission, engineers had already identified several potential failure points before liftoff: vibrational instability during ascent, fuel mixture irregularities, guidance system drift, electrical system overloads. Even a minor malfunction could have resulted in catastrophic failure seconds after launch. But the rocket lifted off successfully. For a brief moment, everything was perfect. The spacecraft climbed through the atmosphere, shedding booster stages as planned, accelerating toward orbital velocity. Controllers on the ground monitored every signal, every reading, every heartbeat of the machine they had built. But space does not stay calm for long. Once the spacecraft reached orbit and began its journey deeper into space, the real danger began. In Earth orbit, small problems can be corrected. But as distance increases, communication delays grow. Repair becomes impossible, and every system begins to operate in isolation, far beyond human reach. One of the earliest issues came from thermal imbalance. One side of the spacecraft was exposed to direct sunlight, while the other remained in the deep shadow. This created extreme temperature differences across the structure. Materials expanded and contracted in ways that were not fully predicted. Instruments began to behave unpredictably. Sensors drifted. Data became unstable. Engineers on Earth had to make rapid adjustments, sending commands that took minutes or hours to reach the spacecraft. Every correction was a delayed response to a problem that was already evolving. Then came radiation exposure. Outside Earth's magnetic field, high-energy particles from the sun and deep space began bombarding the spacecraft. These particles interfered with electronics, caused memory corruption in onboard systems, and introduced random errors in data collection. At one point, scientists noticed that some readings were simply not reliable anymore. The spacecraft was still functioning, but it was no longer fully trustworthy. And yet, the mission continued. Because turning back was not an option. As the spacecraft moved farther away, communication began to weaken. Signals grew faint. Antennas had to be precisely aligned to maintain contact. Even the slightest misalignment could result in complete loss of communication. For long periods of time, Mission Control would sit in silence, waiting for a signal that might not return. And then came the moment that defined the mission's legacy. A critical system on board began to fail. This system was responsible for maintaining orientation, the spacecraft's ability to know which direction it was facing. Without it, antennas could not point toward Earth. Without it, communication would be lost entirely. Without it, the mission would effectively become a drifting object in deep space. Engineers scrambled to diagnose the issue. Commands were sent, backup systems were activated, redundant hardware was engaged. For a moment, nothing changed. The spacecraft drifted. Signal strength dropped. And then, just as contact was about to be lost, a partial recovery occurred. Not a full fix, but enough stability to maintain minimal communication. Enough to keep the mission alive, but only barely. From that point forward, the mission was no longer smooth exploration. It became survival. Every day was a calculation. Every correction was a risk. Every signal was fragile. Despite all of this, the spacecraft continued to send back data. Information about cosmic radiation, measurements of interstellar particles, observations of distant planetary bodies. Even as it struggled to maintain basic stability, it continued to fulfill its mission. And this is what makes it so extraordinary. Because most people imagine space exploration as controlled, precise, and predictable. But in reality, some of the most important missions in history survive, not because everything works, but because enough things fail in manageable ways. Eventually, the spacecraft reached a point where its journey transitioned from active mission to long-term drift. Communication became sporadic. Systems degraded slowly over time. But even then, it did not immediately fail. Instead, it continued moving outward, far beyond what it was originally designed for. At that point, the mission had already succeeded in ways no one could have fully predicted. It had survived extreme conditions, multiple system failures, and communication breakdowns that should have ended it entirely. And yet, it endured. Today, this mission stands as a reminder of how fragile and powerful human exploration truly is. It shows that space is not a place of certainty, but a place of constant risk. It demonstrates that every signal sent from Earth is a message traveling into an environment that does not forgive mistakes. And most importantly, it proves that even the most dangerous missions can become the most important ones. Because in the end, this was not just a mission about technology. It was a mission about persistence, about pushing forward even when systems fail, about continuing when communication weakens, about surviving in an environment that was never meant for us. And that is why it remains known as one of the most dangerous missions NASA ever sent into space. Not because it ended in disaster, but because it came so close, so many times, and still continued forward into the unknown.